All right, so section 5.6, we barely started this right before spring break. You guys made that little foldable thing where you filled out each property. That's what we're learning, and we're going to actually apply some of them today. So there are these three properties. You do have them on the foldable, but I'm going to go ahead and fill them in. So the first one is the product property. Oops, one moment. There we go. So, if you have log base b of m times n, remember two variables put together is multiplication, you can rewrite that as two separate logs added together. So you have log of m plus log of n. Quotient property, similar but slightly different. That's if now your two numbers inside your argument of your log are being divided. You can rewrite that as a subtraction problem. And then the last one is the power property. So if you have log base b of m to the n, okay, just to clarify, you have this base b, argument m. The m is in line with the log. Okay, I know some of you guys keep writing it as an exponent. It's not, and that's going to screw you up now. Then the n is the exponent. You can rewrite this as n times log base b of m. So all that changed was that exponent n moved down in front of the log to become n. So how do you actually apply this? Well, you use these to actually expand logarithms. You can also condense them. So the first thing we're going to do is expand. So here on letter A, you have log base 5 of a squared times b to the 7th. So I'm trying to separate this out. The first thing I'm going to do is, since this is a multiplication problem, I'm going to use the product property to rewrite it as an addition problem. So I have log base 5 of a squared plus log base 5 of b to the 7th. That is the product property. All I did was rewrite it as an addition problem. You keep the base the same in both of them. Both of them are base 5, just to clarify. Now I want to get rid of my exponents. So I'm going to take this 2, bring it down in front, and this 7 and bring it down in front. That's that power property. So I'm going to rewrite this as 2 log base 5 of a plus 7 log base 5 of b. That is the power property. And that's it. That's your answer. You can't do anything else. There's only one thing in each argument, and there's no exponents. That's how you know you're done. Then letter B, now you have a quotient. Okay, you have natural log, ln is natural log, of 25 over 3. So I'm going to rewrite it using the quotient property as a subtraction problem. So I have ln 25 minus ln 3. That is the quotient property. You can also think of it, sometimes this seems to help people, the numerator is positive, so 25 is the positive log. The denominator is negative, so ln 3 is a negative log. But you can also just think of it as top minus the bottom. All right, so that is expanding. Now we're going to do condensing. So on example 2 here, now you see you have several logs being added or subtracted together. The first property you always want to do when you are condensing is the power property if it applies. So whenever you have a coefficient in front of the log, that means that you can use the power property. So here I have this 4 and this 3. Those are coefficients. I'm going to bring them into each log as an exponent using the power property. So I'm going to say log base 4 of m to the 4th plus log base 4 of n to the 3rd minus log base 4 of p. That is the power property. Then you want to apply either the product or quotient property. So I'm going to start with the ones that are being added together. Okay, so these two are being added together. When they're added together, that's when you can use the product property. So I'm going to rewrite them as one log, but multiply the two arguments together. So I have log base 4 of m to the 4th, n to the 3rd, minus log base 4 of p. So I then just move that part down there. That is the product property. And now I have a subtraction problem. So I'm going to rewrite it as 1 log now, but put these two arguments together as a quotient, so as a fraction. So I have log base 4 of m to the 4th n to the 3rd over p. That is the quotient property. So once you have condensed it down to 1 log, that's your answer. That's as simple as you can make it. So again, it might help you to think of, for the quotient property, the positive log. So this one, that one becomes your numerator. The negative log, so this one, becomes your denominator. All right, so same thing on letter B. Again, you want to get rid of your coefficients first. So this 3, I'm going to end up bringing in, and this 2. It's not negative 2. That's part of a different property. So just look at the coefficient as it is. So first of all, I have ln 2 to the 3rd minus ln 5 squared. That would be that power property. Now I have a subtraction problem, so I can apply the quotient property. So I'm going to rewrite it as 1 log, natural log. The positive one becomes my numerator. The negative one becomes my denominator. So that would be my quotient property. Then since this one you can actually simplify a little bit, so I'm going to actually do my exponents, apply them. So I have natural log 2 to the 3rd, 2 times 2 times 2 is 8. 5 squared, 5 times 5 is 25. That would be my answer then. So that is the simplified version of that. All right, so that's condensing and expanding. Now we're going to learn the change of base formula. This is also on that foldable you guys did right before spring break. It's pretty straightforward. So I have log base b of m. Change of base formula says I can rewrite this as log m over log b. So I'm rewriting it with the argument on top, the base on the bottom. So you can also think of this as the argument over the base. The reason that we learned change of base formula is before you had your fancy schmancy calculators you have now, this is what you had to do. If you are one of those people who has a TI-83, so the older model of the calculator, you can solve any log by using the change of base formula. So on example 3, it says, how can you use base 10 logarithms to evaluate log base 2 of 3? So I'm going to rewrite this as the log of my argument, which is 3, the big number's 3, over log 2, my base. Then you just plug that into your calculator. You can just plug it in like it is here. Log 3 divided by log 2, or set it up as a fraction. It should give you about 1.585. And again, go to 3 or 4 decimal places. Pay attention on your online homework to where it says to round to. That will be important for the online homework. And that's it. That's all you gotta do. Then the last part on example 4, it says, what is the solution of the equation 2 to the x equals 7? Express the solution as a logarithm and then evaluate. Round to the nearest thousandth. Okay, so I'm going to rewrite the equation that it gave you here. You're trying to figure out what x is. So the first thing I'm going to do is rewrite this as a log. So remember, that is when you use your little ghost. Bing, and you're going to rewrite the numbers in the correct order. So again, the format you always start with is just log. The first number where we started the ghost is 2, so that's my base. Then I went to the 7, so my argument is 7. And then that equals my exponent, or the ghost ended, x. So now I'm going to rewrite this using the change of base formula. So I have x equals log of my argument, or 7, or log of the bigger number, if you want to think of it that way, over log of my base, or 2, log of the smaller number. Then you just plug that into your calculator. So once you plug that into your calculator, you should get about 2.807. Again, 3 or 4 decimal places. Pay attention. I'm writing this because I know some of you probably are not listening. Pay attention to decimal places on online homework. All right, that's my word of advice. That's it. Again, if you have questions, email me or schedule a Google Hangout appointment with me.